Hello and welcome to the York Observatory YouTube TeleTube, the online astronomy and astrophysics program written and presented by the students, faculty, alumni, and friends of York University. I'll be one of your hosts today this evening. My name is Dhyan, and I'm joined by Maheen, Dorsa, Nakul, and Arfa, and of course, our guest this evening, Alex Innanen. We are broadcasting live from Alan I. Carswell Observatory, located at York University in Toronto, Ontario. Sorry about that. York YouTube broadcasts every Wednesday night at 7:30 p.m. local Toronto time. For any questions or comments you have of our past shows, or if you have any suggestions for future topics, please send us an email at observe@yorku.ca. You can always connect with us on Twitter or Instagram with the handle at York Observatory and Facebook at Alan I. Carswell Obs. So once again, good evening, everyone. We're here from Alan I. Carswell Observatory at York University. Tonight, we have a great presentation about the Martian climate, more specifically, an overview of clouds on Mars, including different types of clouds and the history of cloud observations from the Mariner spacecraft to the present day. We will also explore the similarities and differences between Earth-based and Martian clouds and why we are interested in studying clouds on Mars. And of course, this interesting topic will be presented by our special guest speaker, Alex Innanen, who we will introduce in just a second. Before we do that though, we would just like to mention that the observatory at your campus is in Toronto, and we would like to welcome you to our show and to acknowledge the traditional land that our telescope is on. The observatory acknowledges its presence on the traditional territory of many indigenous nations. The area known as Toronto has been taken care of by the Anishinaabe Nation, the Haudenosaunee Confederacy, and the Huron-Wendat and the Métis. It is now home to many indigenous peoples. We acknowledge the current treaty holders, the Mississaugas of the Credit First Nation. Our stargazing and astronomical efforts join the long history and current practices of astronomy for this land. The observatory looks forward to continuing to learn and revitalizing our knowledge in this area. And now I'll pass it on to Maheen, who will give us a quick update on what's up in the sky this week before we get into today's main topic.
Thank you, Dhyan. Welcome again, everyone. Before we get started with our main show, we want to give you a little update on what you can see this coming week. This week, we have some interesting events happening, which you should look out for. On Friday, May 27th, a pretty sight for early risers in the eastern sky from a very slim crescent of the old moon, which will shine just to the lower left, which is the celestial east of the extremely bright planet Venus. Mars and Jupiter will accompany them, off to their upper right. In the eastern pre-dawn sky on the morning of Sunday, May 29th, the faster motion of Mars will carry it past much brighter Jupiter in a very tight conjunction, resulting in both planets sharing the view in a telescope from Friday to Tuesday, with Mars approaching from the right, celestial west. Tonight, Arcturus and Vega will be visible, which can be spotted with the naked eye. Vega is a part of the constellation Lyra and will be visible as a bright bluish star, whereas Arcturus can be found by locating the Big Dipper. Don't forget to keep an eye out for these. I will now hand it over. Before I hand it over to Arfa, I would like to mention that the current moon phase is waning crescent with an illumination of 19%. And since watching the moon is always a treat, if you want to see some live images from the recent lunar eclipse that happened on May 15th, see our previous week's broadcast and recap episodes. You'll sure find some great images. I'll now hand it over to Arfa to introduce our wonderful guest speaker for tonight.
Thank you, Maheen. So our today's guest speaker is Alex Innanen, who is a PhD candidate in planetary science at York University. Planetary science, if you may ask, is the study about the atmosphere of Mars. In this field of study, one of the most important research work is done on Martian atmosphere, water vapor, cloud microphysical properties, and interaction between the atmosphere and South Pole. Their PhD work is on developing instrumentation for planetary atmospheric applications. Our guest speaker, Alex, is also working in with the Curiosity Rover team, part of the environmental science team, taking part in science operations. We are so glad to have you with us today. If you want to connect to our speaker, you can find them on Twitter at Eternal Library. Now, take it away, Alex.
Thank you so much for that introduction. Hi, everyone. My name's Alex, as previously mentioned, and I'm a student at York University, and I'm going to be talking today about Martian clouds. So I'd like to start off with a bit about water on Mars. Water on Mars is a topic with a long history. Previously, astronomers noticed these channels, these straight lines on Mars, and they called them, Schiaparelli called them channels, and then English-speaking astronomers called them canals, and this map shows Percival Lowell's illustration of these supposed canals, and some people thought, well, maybe they're irrigation canals that Martians created to bring water down from the north and south poles into the equator, where it's much drier. Of course, we found out that these canals weren't real, but there is water on Mars, not liquid water though. And most of the water that is on Mars is in the form of ice in the poles. But there is interplay between the water in the poles and into the atmosphere. This is known as the water cycle. So throughout the Martian year, in the northern spring, water sublimates from the North Pole, so it turns from water ice into water vapor and goes into the atmosphere, gets transported southwards, forming clouds. And then as we move into the southern spring, the same thing happens at the South Pole. So water vapor or water ice turns to water vapor, gets transported northwards. And this cycle happens every year and is important for cycling water through the atmosphere. So moving on to clouds, one first observation of potential clouds was done by William Herschel, who is also the guy who discovered Uranus. And he wrote this extremely long paper talking about all of his observations that he had done on Mars. But in particular, he had these three diagrams of what he thought were clouds that were these bright and dark features that he saw on Mars. And he concludes this paper saying that he thinks that the planet probably has a considerable but moderate atmosphere, so that its inhabitants probably enjoy a situation in many respects similar to ours. So he wasn't quite right about that, but he was right about the presence of clouds on Mars. So as we move into the 20th century, we start sending spacecraft to Mars and we start getting back pictures, and they do show these clouds on Mars. So on the left, on this side, we have the Mariner 4 picture, which is one of the first up close pictures of Mars. And you can actually see some clouds just off the limb of the planet here. And then in Mariner 9, that was one of the first definitive detections of water ice clouds. And you can kind of see these wispy water ice clouds around the mountains. And I'll talk a little bit more later about clouds that form around mountains. But I do want to go on a tangent about this Mariner 4 picture because it's my favorite thing. So as I said, this is one of the first up close pictures of Mars. So Mariner 4, it didn't go into orbit around Mars, but it did a flyby and it sent back this picture. But the picture took a while, several hours to resolve on the computers, and the scientists wanted to make sure the camera was working. So what they ended up doing was they had all of the array of values for the picture. It just hadn't formed on the computer yet. So they printed out this array of values, and each number represented how bright or how dark the picture was. And so they assigned each kind of range of values a color from dark to light, and they colored it in kind of like a color by numbers, and they created that picture before the computer could even resolve it. Just think that's very cool. So I mentioned water ice clouds. So what does this mean? So water ice clouds, as opposed to water droplet clouds, I guess, are formed of water ice crystals. So on the side here, you can see a number of different shapes that water ice crystals form. So on Earth, cirrus clouds are water ice, and they tend to be formed higher up in the atmosphere where it's colder. And these are the kind of wispy, sometimes they're called mare's tails clouds. And we do get the same kinds of water ice clouds on Mars. So at the top, this is a picture I took just a few days ago at York University, actually, of some clouds. And then on the bottom, this is a picture from the Opportunity rover. And you can see a lot of similar shapes in kind of these wispy clouds, which is just very cool. So thinking about water ice clouds makes you have to think, does it rain or snow on Mars? And yes, kind of. So there is carbon dioxide snow, and you can see in this bottom picture the carbon dioxide frost or snow on the surface of Mars, but also there have been detections of water ice snow. So this colorful nonsense at the top is taken by LiDAR, which is a laser, basically, and the laser beam reflects off particles, and you can tell things about their height, their properties, and those kinds of things. But what's very exciting about this is that you see the cloud, but you also see these fall streaks, which are heavier water ice particles actually falling down out of the clouds, kind of like snow. So that's very cool. For the rain question, it doesn't rain on Mars because Mars cannot support liquid water. Aside from water ice clouds, we also see carbon dioxide clouds. And carbon dioxide, because Mars is much colder, is able to freeze and become more stable there. So here we have carbon dioxide ice, it's called dry ice. And you know, it's often used in smoke machines and stuff because it immediately wants to turn into vapor in our atmosphere. But the polar caps, which I showed earlier, are actually in the winters covered in a layer of carbon dioxide ice. And we also get these carbon dioxide clouds. And it's not always easy to tell the difference between water ice and carbon dioxide clouds. So in the lower picture, you can see there's some color happening there. So if you have a camera that can see into color, sometimes the colors of the clouds can help you determine what kind of particles they're made out of. And then the other thing that we can use sometimes is the height. So carbon dioxide clouds tend to form higher where it's colder than water ice clouds. So I'm going to go through some different kinds of water ice clouds and places where they form. So we have polar clouds, which, as the name suggests, formed by the poles. So on the right here, you can see what's called a polar hood clouds, and these are kind of cover the poles in the winters. So these are northern polar hood clouds that are forming in the northern winter. And then also you get these spiral cloud formations sometimes around the poles, which are really cool and look a little bit like cyclones or hurricanes. We also have what are called orthographic clouds, and that just means that they form because of mountains. So in the bottom, you can see clouds forming around Olympus Mons here, and this row of 3 volcanoes called the Sarsis Montes. And these clouds form because of air being forced up over the mountains. So moist air gets forced up, and as it ascends to where the atmosphere is colder, the water in the air freezes into water ice crystals and forms clouds. And you can also see this very long cloud by what's called RCM Mons, and I'm going to tell a little story about that because it's also very cool. So this is called the RCM Mons elongated cloud, very originally named, and it has been observed for years and years and years. Actually, it was observed by Viking back in the 70s, and people were kind of catching glimpses of it every now and again when the orbit was right and stuff, and no one really knew why it was forming. It almost looks like the volcano is active and spewing out smoke or something, but that's not the case. So recently, the visual monitoring camera on Mars Express was able to actually take a bunch of systematic images of the cloud. And they were able to see that it was forming in the mornings. It expanded at a rate of about 600 kilometers an hour, which is just wildly fast. And it tends to expand every morning in this cycle for several months in the early mornings. And then when the atmosphere, when the sun comes higher and the atmosphere heats up, it tends to dissipate. So the last cloud feature that I want to talk about is called the aphelion cloud belt. And this is a belt of clouds that encircle the equator around aphelion, which means the time in Mars's orbit when it's the furthest from the sun. And yeah, so this is greater cloud formation that just happens, and it's really distinctive how much you can see it in these two Hubble images, this ring of clouds right around the equator of the planet. And what's great about the aphelion cloud belt is that this star right here, that's where Curiosity is. So Curiosity is in Gale Crater, which is about 5 degrees south of the equator. So it's perfectly positioned right within the aphelion cloud belt, and is able to look at these clouds every year. And Curiosity has now been on Mars for over 5 Mars years. So we've been able to see a lot of aphelion seasons, which is great. And I'm going to show some pictures from that now, because I'm part of the MSL mission, and it's taken some really stunning pictures. So these are actually twilight clouds, which I will talk a bit more about later. But we've seen lots of different water ice clouds, and these are some cool features that we see in the clouds. So we've got kind of these ripply clouds, and the ones in the lower part of the screen here that are called gravity waves. And that's just particles kind of rising and falling to different altitudes and condensing at higher altitudes and not at lower altitudes that give the clouds this kind of ripple shape. And we've seen quite a lot of those in Gale Crater, which is very neat. This is there's a very recent press release of an observation of what are probably carbon dioxide clouds. And this observation is one that my colleague Carissa Campbell does. And so this image on the right here is looking straight above. And then the one where you can see the shadows is looking at the mountain in the middle of Gale Crater. And so these are the same clouds, and it's really cool that you can actually see the shadow moving, and this allows us to tell how high these clouds are. And this is what tells us that these are probably carbon dioxide clouds is their height. But it's just really cool, the science that we can do with these cloud images. And then this is probably my favorite cloud image ever. So this was earlier, well, it was about a year ago now, earlier this Mars year, at a location called Mamarku, which is this cliff face that you can see in the front. And behind it, you can see these beautiful twilight clouds. So twilight clouds are clouds that we have observed forming early in the Mars year. So this is the southern autumn for us. And as the sun sets, these clouds are actually high enough that they're still illuminated as the sun goes below the horizon. And these clouds almost appear to glow, which is really cool. And there are clouds like this here on Earth. They're called noctilucent clouds or night illuminated clouds. And you can also do some cool science with these clouds. So this is a little movie just showing the motion of the clouds, and also you can see the shadow of the sun as it sets moving across the clouds, and the speed that the darkness kind of overtakes these clouds can tell you about how high up these clouds are. And you can use that to determine things like, could they be water ice or could they be carbon dioxide? And these are just some more of those noctilucent clouds from Mars year 35. So that's, yeah, I'm gonna leave you with this beautiful picture of some Mars clouds. And thank you so much for listening. And I'll turn it back over to the observatory.
All right, so we'll move on to some questions. I think Dorsa has a question for you first.
Hello, Alex. Thank you so much for your presentation. My question for you is, out of the wide scope of topic regarding the Martian atmosphere, how and why did you come across focusing on cloud microphysical properties and the interactions that you were previously talking about?
Partly to do with we do a lot of work with clouds in the lab group that I'm a part of. So it was partly that. It's also, it's an important part. I didn't get super into this, but it is an important part of a bunch of processes in the atmosphere. So clouds can affect how much solar radiation is coming into Mars. They can change the temperature of the planet. That aphelion cloud belt that forms, that actually stops water vapor coming from the North Pole, getting all the way to the South Pole. It kind of traps it around the equator. So studying clouds can kind of affect a lot of things, which is really interesting. And yeah, also you get to look at pretty movies, which is cool.
Thank you very much.
Hi, so I just have one question. By the way, it was an amazing presentation. I really loved it. So my question is, why are we doing so much research on Mars and not the other planets? What makes this planet so special?
I think there's a couple of reasons for that. One, I'm kind of biased. Mars is the best planet. No, but I think partly it's that it's so close. It's relatively easy to send spacecraft to, especially compared to like the outer planets. And I partly also, it is in so many respects very similar to Earth. Like the length of its day is only 40 minutes longer. It has seasons like we do. It has, like, as I showed, it has clouds and snow and fog and a lot of similar processes to what we have on Earth. So it's almost like, I don't know, a cool little reflection of Earth, but does have some significant differences, and in some ways is simpler and in some ways is more complex. So yeah, I think it's just very interesting to study in that way.
Thank you.
Hi, Alex. I have a couple questions. So my first question is, we know that Mars contains like almost no oxygen, right? How does that affect cloud formation on the planet, like if at all?
Okay, I'm not entirely sure, but it doesn't seem to impact it too much. I mean, clouds are still forming because there is enough water vapor in the atmosphere, even though there are very, 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 very small amounts of water vapor and oxygen. But it's still able to, there is enough, I guess, to still condense and form water ice crystals, which is, yeah, it's neat how, like, even though the atmosphere is so different, we still get very similar clouds.
Oh, thank you. And my second question was, could you go into a little more detail on your work with the Curiosity rover?
Yes. So my supervisor, Dr. John Moores, is what's called a participating scientist on the Curiosity mission. And so a number of his grad students get to be what are called participating scientist collaborators. Basically what this means is that we get the opportunity to do science operations on the mission. So I'm part of the environmental science team. So we have a hand in planning the science activities that the rover does. So putting in things like those cloud observations that make those movies, monitoring dust, and monitoring kind of the atmosphere and those kinds of things. And working with the other big science group, which is the geo team, who are mostly looking at rocks to kind of fit in our observations. And we also can, if we have ideas, suggest other observations and stuff like that. And it's like the coolest thing I've ever done. It's definitely an amazing opportunity, and I really love doing it. Yeah.
So you kind of like get a vote in like the activities that the rover gets to do.
Yeah, yeah.
Oh, that's really cool.
We have kind of a schedule of what observations we want, and we just try to fit them in as best as we can, working with power constraints and things like that.
That's really cool. Thank you. I think Maheen has a couple questions now, so I'll pass it to her.
Thanks, Dhyan. So I also have two questions. So my first question is the sky on Mars blue like it is on Earth?
That's a really good question. So in that picture that you're showing right there, it's kind of showing this like tan, weird colored sky, and that is what the sky looks like if you're standing on the surface of Mars. Which is really weird. Sometimes you'll see images from Mars and the sky will look blue, but that is, they sometimes do like corrections to the images after it comes back to get, to make it look like it would if you were on, like if that image was on Earth. So it does give Mars an artificially blue sky, but like in actuality, you would see more of this kind of tan, salmon-y colored sky. But what is interesting is that Mars has blue sunsets. And there's a really beautiful Spirit picture from the Spirit rover of a blue sunset, which is fairly famous. I think if you Google like Spirit blue sunset, it comes up. Yeah.
That's actually quite interesting. So I also have another question. So do dust storms play a role in the formation of Martian clouds?
They do, yeah. It's really cool. So there was a dust storm in there was a big dust storm. Mars has these things called global dust storms, which are basically, it's a giant dust storm that covers the entire planet. And in 2018, there was a global dust storm. And they actually saw, there were a number of papers, they saw different clouds forming that they like wouldn't expect to see at those times of year. There were some like clouds forming around twilight, and there were really high altitude clouds and things like that. something in the changes in the atmosphere that the dust storm caused actually created the formation of different clouds.
I see. Thank you. I think Nakul has a question for you as well.
Hi, my question is, do you think investing a lot of money towards the Mars in the name of new habitat worthy? I mean, is it worthy since Mars is not a stable living planet right now? So most of the scientists are investing on it. So do you think is it worthy?
Yeah, no. I'm not sure if this is a controversial opinion. I don't think we should be trying to make Mars like a quote unquote new home for humanity. I think we should be focusing on keeping Earth, which is like the perfect planet for us, good and able to sustain all of us. I think that's way more important than setting up societies or civilized like places to live on Mars. I think going to visit Mars would be cool, doing some science there. There have been times when I've been looking at the South Pole or something, and I think to myself like, oh man, this would be so great if I could just like have someone stick a thermometer in the ground. But yeah, no, Mars is not, it's not a good place for us to live. It would be very, very, very difficult for us to live on Mars, whereas it's a lot less difficult for us to live on Earth. So yeah, that's my kind of ranty answer to that question.
That was really interesting. And almost we're at the end now. Do you have anything to say to add up anymore?
I don't think so. Just yeah, Mars is cool. I don't yeah. Thank you again so much for having me on to talk about this.
And that's really cool to have you here for our TeleTube today. And thank you, Alex, for joining us as a guest for today's TeleTube. And well, everyone, you have been listening to the Allen Caswell's Observatory's weekly TeleTube podcast, the Astronomy and Astrophysics program, written and presented by the students, faculty, alumni, and friends of York University. The host this evening has been Dhyan, Arfa, Maheen, Dorsa, and myself, Nakul. Make sure to leave any comments or questions in the comment section of the video and talk to us in the chat right now. We'll be around for the next 20 minutes to answer your questions. All of our programs are free, but if you would like to make a donation, see our website at observatory.info.yorku.ca. You can always connect with us on Twitter with the handle York Observatory and check out our website for show notes, contents, updates, and contact info at observatory.info.yorku.ca. Thanks for tuning in, clear skies, and have a good night.